Introduction to Statistics, Chapter 4, Describing the Relation Between Two Variables, Section 4.2, Least Squares Regression. Least Squares Regression Line. The least squares regression line is the line that minimizes the sum of the squared errors, or residuals. A residual is the difference between an observed value and a predicted value. The equation of the least squares regression line is y hat equals b1x plus b naught. Y hat is the predicted value for y. b1 is the slope of the least squares regression line. b naught is the y-intercept of the least squares regression line. This is very similar to the slope-intercept form equation from algebra, y equals mx plus b, where m was the slope and b was the y-intercept. Be aware, the book uses the formula y hat equals b1x plus b naught, and StatCrunch uses the formula y hat equals b naught plus b1x. They are the same formula, just written in different forms. Also note the point x bar, y bar, where x bar is the mean of the explanatory variable and y bar is the mean of the responsive variable, are on the least squares regression line. Understanding the interpretation of slope and the y-intercept of the least squares regression line. Example 1. If weight of a car is explanatory variable, miles per gallon is a response variable, and the least squares regression line is y hat equals negative 0.0025x plus 28. What does the slope imply? For every increase of a pound in a car's weight, the miles per gallon decreases by 0.025 miles. What does the y-intercept imply? It does not make sense to interpret the y-intercept because a zero weight of a car does not make sense. Could a car weigh zero? Would we have a car that weighs zero? No, it doesn't make sense, so the y-intercept would not make sense. Example 2. If the number of kilowatts used is the explanatory variable, price you pay on your electric bill, the response variable, and the least squares regression line is y hat equals 0.25x plus 25. What does the slope imply? For every increase of a kilowatt used, your electric bill increases by $0.25. What does the y-intercept imply? It implies that if you use 0 kilowatts, your electric bill will be $25. And can we use 0 kilowatts? Yes. If you had nothing turned on in the house, you would still pay a basic fee of $25. Finding the least squares regression line by hand when given 2 points. You're going to be asked to find the least regression line when they give you 2 points. This is going to have to be done by hand. Now, first you're going to have to recall the equation for finding the slope of a line. M equals y2 minus y1 over x2 minus x1, the change in the y's over the change in the x's, and find the slope of the line passing through the 2 points. Then you're going to have to recall the point slope equation. Y minus y1 equals m times x minus x1, and find the equation of the line passing through the given points. This is all going back to your Algebra 1, Algebra 2 in high school. Example, find the line passing through 3, 8, and 5, 12. First, find slope. Slope is going to be 12 minus 8 over 5 minus 3. 4 over 2, which is 2, so the slope is 2. Next, find equation of the line. So y minus 8 is going to equal 2 times x minus 3. So we multiply out, we get y minus 8 equals 2x minus 6. Regroup, y equals 2x plus 2. So y equals 2x plus 2 is our equation for the line. Now, find the least squares regression line using StatCrunch when more than 2 points are used to calculate the line. Load the data into StatCrunch. Select Stat in the top menu, highlight regression, select simple linear again. Under the x variable, choose column with explanatory variable. Under the y variable, choose column with for response variable. Click compute. This will be your output. Now, your linear regression line will be right here. y1 equals 14.064727. minus 0.50981818x1. You notice it's written in the form y hat equals b naught minus b1x, or plus b1x. Now, you will need to understand the value of the slope and the value of the y-intercept and place them in the correct spaces when entering your answer in StatCrunch. So, another way, instead of just looking at the equation up above, you can also look, right here is the y-intercept. If you notice, it's the same thing that was up in the equation. Right here is the slope, which is the same that was in the equation. So you can look here for the intercept slope, or you can look up in the equation. But remember, the slope is always associated with the explanatory variable. Least squares regression line. Making predictions for a data value within the range of explanatory values. If a linear relation exists between the two variables as discussed in section 4.1, and the value is within the range of the data values used to compute the least squares regression line, you may use the least squares regression line to make a prediction for the data value. But you have to have a linear relation first. Second, if a linear relation does not exist between the variables and the value is within the range of the data values used to compute the least squares regression line, you may not use the least squares regression line to make a prediction for the data value. You will use the mean of the y values as your prediction. So if it's not a linear regression, your prediction will always be the mean of the y values. And of course, if the value is not within the range of the data values used to compute the least squares regression line, you may not make a prediction for the data value. Finding the residuals and sum of the squares of the residuals by hand when given 2 points. Find the least squares regression line by hand. Use the least squares regression line found in step 1 to find a predicted y value for each x value. Take each observed y value minus the predicted y values found in step 2 to find residuals. Take each residual found in step 3, square it, and find the sum of the squares. An example, this is xy, and you're to find the line that passes through 3, 8, 5, 12. Well, first, least squares regression line. We found this earlier, is y equals 2x plus 2. You'd have to go through, find the slope, and then find the equation of the line like we did in earlier slides. So this is the equation we found earlier. Second, add a column, y hat, predicted values for y, and complete. So y hat is going to equal 2 times 0 plus 2 equals 2 for the first one. For the second one, it's 2 times 1 plus 2 equals 4, all the way down. You get all the y hat predicted values. Next, you want to add a column for residuals. This is going to be y minus y hat, the observed minus the predicted, and compute. So it's going to be 3 minus 2, which is 1. 3 minus 4, negative 1. 7 minus 6 is 1. 8 minus 8 is 0. 13 minus 10 is 3. 12 minus 12 is 0. Next, add a column for residuals squared. Take each residual and square it. 1 squared is 1. Negative 1 squared is 1. 1 squared is 1. 0 squared is 0. 3 squared is 9. 0 squared is 0. And finally, fifth, compute the sum of the squared residuals. So if I just add up the residuals squared, I get 12. So that's the sum of the squared residuals. This is doing it by hand. And most of the ones you have to do by hand, the equations come out fairly nice with whole numbers for your slope and your y-intercept. Now, finding the residuals and sum of the squares residuals using StatCrunch. Load the data into StatCrunch. Choose Stat, Regression, Simple Linear. Under the x variable, choose Explanatory Variable. Choose the response variable for the y variable. Now, this time, under Save, choose Residuals. We want the computer to automatically calculate the residuals. So click Compute. Now this would be your output, okay? You will get this normal output of statistics here, but you also get the residuals put into your spreadsheet. So right here would be your residuals, okay? Now, next, to find the sum of the squared residuals, first click on any blank space in the spreadsheet. Select Data on the top menu, highlight Compute, and select Expression. Under Expression, click Build, find Sum and Functions, and double-click Residuals under Columns. Click the up arrow on the keypad, or the caret, sometimes referred to, and click 2 on the keypad. Click OK, and then click Compute. And your residual, your sum of the squared residuals will show up in the first blank space of the next column not used. So it will show up right here in variable 4, first space. Okay, let's look at using StatCrunch. So here's the first question you might run into. If the linear correlation between two variables is negative, what can be said about the slope of the regression line? Remember, if it's a negative correlation, that means it's going down as you go to the right, which means it's going to have a negative slope. We're calling back to algebra. All right, next question. Is the statement below true or false? The least squares regression line always travels through the point x bar, y bar. Remember, x bar is the mean of the x's, y bar is the mean of the y's. And yes, the least squares regression line always passes through that point. That's true. Now, we're given a set of data. They want you to draw a scatter diagram, connect on the type of relation that appears to exist between x and y. So, at this point, what I can do is I can open my data in StatCrunch, just like we did in section 4.1, stat, regression, simple linear, choose my x value, choose my y value, click compute. I get this picture. All right, let me go here and get this to the right side of the screen, window right, and let me click on this and put this to the left side. Okay, so now we have the right and the left. Okay, so if I click the arrow, now I see my scatter plot. So I got to decide, is it going to be A, B, C, or D? Well, I can almost throw D out. I can probably throw C out. So it's going to be A or B, and if I look closely, it's pretty, these 2 points here apart, so I'm going to say it's going to be B. And if I wanted to, I could enlarge this, magnify it, and yes, you would see that it is almost exactly what I have over here. It's just the starting points for the y value and the x value may be different. Okay? But you should be able to see. So what did I say that was? B, right? Okay, there appears to be, so look at this relationship. There appears to be a linear positive, no, a nonlinear, a linear negative, a constant. Well, do those points look like they follow a line? Yeah, pretty much. They follow it a little bit. And which way is it going? As you go to the right, it's going down, so that would be a negative. So I'm going to say a linear negative regression. Now it wants to know what the regression line is, so I hit the back arrow, go back, and I can go up here to this, right here, y equals 6.453 minus c. But now you notice this over here is written as blank x plus blank. So I got to reverse what I get over here to StatCrunch over here. So this first one is going to be my slope, which is going to be negative 0.645, and they wanted 3 decimal places. Okay. And my y-intercept is going to be 6.453. And again, I could have looked for here for the slope and here for the y-intercept. Okay. Now choose the correct graph below. This time, all they're going to do is put the least squares regression line on the graph. So what you want to do is go up here. This was your original graph. So you should have the same graph down below, but this time with a line through it. So which one of these graphs looks like that first one with a line through it? Well, if I could go over here, go back to my scatter plot, this looks like it. So I'm going to say it looks like B again, right? It almost looks like this, it looks like this. So we're going to say B again. And if I expanded it, you would see that it's basically the same thing I have over here. Alright, next problem. Complete parts A through H for the graph below. Now, so first if I load the data into StatCrunch, pin it to the right. Now, I need my stat diagram, scatter diagram again. So stat, regression, simple linear. Excuse me. I pick the X, pick the Y. Now, go down here, hit compute. Here's my data, but I need the scatter plot, so I hit the right arrow down at the bottom. Here's my scatter plot. So which one does this look like? Well, if I look at A, that doesn't look like it. B looks like it's in a straight line. I'm not in a straight line. This is C. These 2 points in here look a little bit out. D, let me expand D just to be on the safe side. And yeah, it's looking pretty much like D. Okay, so this is a visual. So D would be my answer. Now, here's the problem. It says find the equation line containing the points 3, 6. Now we're going to have to do this by hand. 3, 6, 8, 21. So I got to go to scratch paper to do this. Let me see if I can remember. 3, 6, 8, 21. So if I go over here, I'm going to have 3, 6, 8, 21. Alright, now for the slope, remember the slope was the change in the y's divided by the change in the x's. So I would take the 21 minus the 6 divided by the 8 minus 3. And if I do this, 21 minus 6 is going to be 15, divided by 8 minus 3 is 5, which equals 3. So the slope of the line is 3. This is what we talked about. Now for the equation, you're going to take y minus y1. So I'm going to take y minus 6, let's say, equals the slope, which is 3, times x minus x1, which is 3. Now I do the math. I get y minus 6 equals 3x minus 9. And then if I regroup, y equals 3x minus, take the 6 over, it'd be a positive, so that's going to give me a negative 3. So there would be my equation, 3x minus 3. Now if I go back to my problem, I enter 3x minus 3. I'm going to put a 3x here, but in this box I'm going to have to put a negative 3 because it's minus 3. Alright, next. Graph the line found in part B on the scatter diagram chose. So choose the correct diagram. So if I go back up here, which we chose D, right? So this was D. Which one of these looks like D? It looks like D again, right? It doesn't always turn out to be this. Well, let me double check. Yeah. So it's going to be D again. And if I look at this, there's my points. And if I would go back and look at D from the beginning, same set of points. Okay? So it's D in this case. Doesn't always be the same one. Now, by hand determine the least squares regression line. Well, it says by hand, but this means we're using the all the data. So we can go back to what we did in StatCrunch. Go back here. Here's your equation of your line. Down here's your slope. There's your y-intercept. So our slope for this line to 3 decimal places would have been 3.047. and the y-intercept would have been negative 3.651. You notice this equation is a little different than the first equation. This equation is, they're close, but a little different because we used more points here than we did up here. So I'm going to be a little more accurate. Now, which graph is it going to be? Well, again, the graph is going to be very similar to what we had before. So if I look over here at this graph, this looks like it's going to be D again. Now, compute the sum of the squares of the residuals for the line found in part B. Well, if we go up here to part B, this was my equation for part B. So I need to find the residuals using predictions. So what I have to do is go up here and predict each one of these and find their residuals. So if I throw in 3 in here, 3 times 3 is 9, minus 3 is 6. So I get the same answer, 6. If I plug 4 in, I get 12 minus 3, which is 9. Okay. I take 5, that's 15, minus 3 is 12, so this is off. So if I go over here to my what I was doing before, my residuals, okay, the first residual was 0. Second residual was 0. Third residual we said was 2 because we got 12. We got 12 and we had 10 for, actually it's going to be a negative 2. So I got back and change that. Okay, 3 times 7 is 21. 21 minus 3 is 18. So that's a 0. So let me go back. So this we said was a negative 2. Next one is 0. And the last one, 3 times 8 is 24. 24 minus 3 is 21. So that's a 0. Back to the power. So there are my residuals. And now if I want the sum of the squared residuals, I take each one of these, square it, add them up, and in this case you would end up with 4 for the sum of the squares of the residuals. So if I go back to my problem, now I can go down here and say round to 3 decimal places as needed. Well, there's no rounding needed. It's going to be 4. And now compute the sum of the squared residuals for the least squares line found in D. Well, now I'm going to go back to my StatCrunch. Go back here. Now, under options, I'm going to click options. I'm going to edit. Remember I said if I want the residuals under save, I'm going to hit residuals. Now click compute. You notice it put my residuals over here in the spreadsheet. Now what I want to do is click on my spreadsheet, anywhere in the spreadsheet, go under data, go down to compute, expression. Under expression, I'm going to hit build. Now what did I say I wanted? I want the sum of the squared residuals. So over here under functions, I scroll down until I find sum. There's sum. Double click, and you notice sum comes up here in the expression line. Now, what do I want the sum of? I want the sum of the residuals. So I double click residuals, and I want to square it. So I hit the caret for squaring and 2. Now this should give me the sum of the residuals squared. Click OK, and then click compute. And right here is the sum of the squares of my residuals, which in this case is 3.163. Now, comment on the fit of the line found in part B versus the least squares regression line found in part D. So, the line in part B passes through most of the points. The line in part B, let's see, this part passes through, maximizes the sum of the, or minimizes. So we go back here. So the line in part B basically passed through most of the points because we only had one that the residual was not 0. All these other points, the residual was 0, so it passed through most of the points. And the one in D, what does the line of least squares do? It minimizes the sum of the squared residuals. Okay? So there's an example where we have to go through those problems. All right. And this is the end of section 4.2.